So, hello slide, yeah, hello slide. So, hello, that's me. And as you can see, I am actually at a pub. So that's the reason for the background noises. Um, but it also makes up for a lot of the feeling of the sessions. Imagine we're meeting in a pub over a beer, or in my case at the moment water, to talk about getting started with the Yocto project. This is the topic for today. Getting started and getting your first build, getting your first build booting. I don't think you have to know anything in advance, just some generic Linux command line knowledge will be fine. And during the session, whenever we have a short amount of waiting time, or if we have time and questions afterwards, the side topic for today is package selection and what you usually want to bring into your image, what are best practices or things that I have found to be worth knowing, because that was a common question. So what do you usually put into an image besides the just core image minimal that we will be talking really soon? So this is the kind of like topic number 2, smaller one. Okay, so let's get started. I hope here is my terminal. Can you see my terminal? Yeah, I think the preview is fine. Okay, so how does anybody get the build started? You get a clone of the Pocky repository, which is located at http no double slash get Yocto. Oh, you got me all confused. Must be the pub. Yocto Project.org Pocky Git. Now, okay, that's it. I messed up. Okay. No. That's it. That's it. Okay. Super confused. That's me. But this is live coding. Things can happen. Things will happen, and that's also a bit of the feeling that we want to get across to you. This is not a pre-recorded web stream with all slides and nice and shiny and nothing goes wrong. Things will go wrong here, and just like anybody who's just standing or sitting right next to you, we will be trying to cope with it and see what's going on. So, I'm just getting a fresh checkout. As you can see, the clone is finished. We will be stepping into Pocky and getting the latest stable release. This means we will hopefully expect less breakage than staying on master. It's not quite as cool, but we're not trying to be cool today. Not yet. We're trying to get things done. And this is the latest tag as mentioned in the quick start tutorial that you can find on www.yoctoproject.org. The tag Yocto 2.7.1 nickname warrior is the latest stable, and we'll be getting that one. So now what do we have? We have downloaded and set up Pocky, which is a reference distribution that's built upon open embedded technology. That's a bit complicated to get your head around, but in a nutshell, it's like this. Open embedded is the technology and a lot of the infrastructure, and Pocky, as provided by the Yocto project, is like a finished reference distribution that you can just take to start out, and that's what we're doing. So we have Pocky. How do we set up the build? We need to source Pocky OE init build environment. There's already a small hint on Open Embedded already. I've stepped out of Pocky, out of the Pocky directory for a reason. Whatever I do, I don't do it in the downloaded repository, which means I can get pull there, I can get newer revisions, check back to earlier revisions, go back and forth essentially without losing or corrupting anything that my work has created. So now that we have it ready, it's almost time to kick off our build. Let me just in an off terminal reserve some time on my build server, because if I'm not doing this, we will be waiting for probably an hour or so, and I don't think this is a lot of fun. So I just need to make sure that nobody else is interfering what I'll trying to show you today. Sorry about the interruption, but if I'd done that before, the sourcing wouldn't have worked. Okay, so here we are, good to go. Bitbake core image minimal. Already something's going wrong. That's what I meant. Things can go wrong, things will go wrong, and I will fix them as we go. Here it is. Okay, so what I have done now is Bitbake Core Image Minimal. Bitbake is the main tool that you will be interacting with if you're doing Open Embedded or Yocto Project development, because it's the task runner, basically. You tell it what you want to have done, and there's something not exactly as I expected it to be. Oh, okay. Things can go wrong, things will go wrong, and I need to interrupt this. I seriously need to interrupt this. Okay. And another try. Okay, this looks better. Bitbake, you tell Bitbake what you want. Basically, you want something being built. So that's why if you don't give it a specific command, then it will just try to build the thing that you are giving it, which in this case is Core Image Minimal. Core Image Minimal is about the blinky of an embedded project. The embedded project always starts out with blinking an LED, and any distribution building project, just like Buildroot or Yocto or anything else that you know, always starts out with building a minimal rootfs in the kernel that you can fire up and say, yes, hey, it boots. And so Bitbake just runs off and does a lot of stuff, and I wonder why it does not exactly do what I expected it to. So this is probably the session where I break up, where I break the most stuff. For the few people who are around today, it will be hilarious. I will be messing up big time today. I feel it. I feel it in my bones. This is really no good. But anyways, so while we're waiting for things to go, just some small organizational things. You can just type stuff into the Twitch chat. I will try to monitor it, and you can also just scroll down, and there's a button or a link right to hash Yocto on Freenode, which when you click, you get redirected to the web chat login at Freenode, and you can just pick a random username and talk to us without any registration or anything. So we're always happy to hear, ask questions, ask things, tell us if we're messing up. We try to get better. Okay, so I can see the question or halfway question. Sometimes I get an error like libdnf native. Generally, this error that you're pointing out suggests that something in the compilation stage of libdnf went wrong, which is strange in terms of libdnf being built in. If such an error occurs, there's always a link to the complete log, and if you look into it, you should usually be able to find out what's going on. If things are being overwhelmingly complicated, which they tend to be in the beginning, just drop the log into a pastebin, head over to hash Yocto on Freenode, and show us the pastebin. We will happily look at it and try to find out what's going on. Do compile failing for something internal like libdnf is strange in terms of it usually being tested quite well. So the only thing that comes to my mind would be that you're on a distribution that brings specific version or problematic versions of glibc. We've had that a couple of times by now, especially if you're on Fedora. Fedora is sometimes a bit too modern and giving us funny experiences. But generally, this really shouldn't be that much of a problem. I'm really wondering why my build is so slow. This is totally not what I expected. Okay, now I got it. Sorry, like I told you, I'll be messing up big time today. And try number 3. All good things are 3. Does this translate? We have a saying in Germany, alle guten Dinge sind 3. Okay, this is what I actually wanted to see. I'll explain in a second why this was super fast now. Does this mean I should drink more or that I should drink less? We will see. So the last step, as you can, or one of the last steps that you can see is now that coreimageminimal do rootfs. This means that all the things that you need for coreimageminimal are just now taken, and it's literally every package being installed, brought together into a file system, and then packed up. And once this is completed, which is this right now, we can see how if it works. By default, Yocto builds for QM-X86, and as I'm on a remote build server, SSH without a graphic connection at this moment, we have to add the no graphic, switch, and here we go. Hooray! It boots, it gives us a kernel log going up, and hopefully in like 2 or 3 seconds we will have a shell. And here it is. What we can see is, if we look at etc OS release, that should be a classic. That's not even here. You can see we are in a root file system running on QEMU. We are on a file system that's about 10 megs in size, and we have used 7 megs. And, okay, here it is. Yocto Project Reference Distribution 271 QMX, whatever. Okay, so what did happen now? We cranked out a build for coreimageminimal, and we used the QEMU that Pocky already prepared for us to try and boot test it. So now it's time for me to explain the speed thing. Yocto, or Open Embedded in general, can reuse a lot of things that it has primarily built, or it has already built. And this is basically what I had to do, because if we couldn't reuse a build that I have already prepared a couple of hours back, then we would be waiting for 2 or 3 hours, literally, for the build to complete. So, as you can see, I switched the download to a primarily to a previously known place, so I don't have to pull all the source down, and the sstate shared state directory also to a prepared place, which means that Bitbag only has to look there. Is the stuff already built? Pull it out, bundle it together into the image, and then we're good to go. Let me check if things are still quiet. Things are still quiet. So if anybody has joined lately, hello everybody. We're just going through the quick start. Basically, we have finished building coreimageminimal. Feel free to say hello in the chat. Feel free to say hello on #Yocto over at Freenode. Link is down there. Click it, pick a name, and just say hello. Tell me whenever I make lots of stupid mistakes. Okay, so now we have an image. It does not do really much. It boots. That's about it. So the usual things that one would do is add functionality to it. That's where we probably digress a bit into the what's common functionality to really add to it. We will add an SSH server as the very first thing. As we're talking about embedded systems, you don't usually want to go for OpenSSH, the big one, because you might be pretty much space restrained. So we want Dropbear. Dropbear has, like all SSH servers, the implication that it needs startup scripts, that it needs keys being generated at boot time. So it does not come as a package alone, it comes as an image feature. Image feature is like big chunks of things that you can just take and smash into the image. And in this case, we want SSH server Dropbear. If anybody of the usual suspects is around, feel free to drop in the link to the dev manual into the jet, maybe with a section to the image features. There's a small list of things that are actually prepared as image features. So we added it to local.conf. Local.conf means this is the tinkering place. This is where you just scribble down things for BitBake to do with that specific build. If you want to go more into reproducible development, you usually will want to bundle things up into your own layer, which I will not be covering today because there's already a session on it. I think it's live with the Yocto project number 2. That's to be found on YouTube. Go check it out. There's a full run of examples on how to create your layer and how to put things in there, creating your own images. This is more like the how to get there session for today. So, coreimageminimal, again, we told BitBake that this time we want Dropper to be installed. So we hopefully see that Dropper is being prepared. Package group Dropper. Dropper has even to be built because I didn't prepare that one. So that's for you to see now. This is about the time that my build server needs to fetch the Dropper package, configure, compile, package, install, and then put it into the root file system again. And it's almost finished. Image complete. We shall be booting this again and hopefully see Dropbear getting started and waiting for incoming connections. This is really one of the things that you usually do as the very first things when you've managed to make your device boot. You will want an SSH server, so you're not only limited to the serial interface that you often have in embedded development. You just have a small look into the running processes, and here it is, Dropbear, exactly what I promised you. Okay, so now we have an SSH server. What are other things that you often will want? You will want things that make your life easier, which means bigger, more fully featured init systems, bigger, more fully featured command line tools. And this is what the first thing that I always do, usually even before I add an SSH server. I switch to, okay, everybody can go bitch at me now. I usually switch to systemd because I personally love systemd. It makes my life so much easier once you're getting the hang of it, especially for journal control. Journal control is saving my life on a daily basis. So we're sticking to the information from the dev manual. I'll drop the link in a second. I have it ready by now. This is what makes the distribution all together. Add systemd and use it as the init manager. We will want a little more. It's all in the manual. We also will want sys5init to be removed, and all of its init scripts too. I really don't need them. And here we go. And again, things can go wrong, things will go wrong. I thought it would work if I just leave the spaces in, which it obviously doesn't do. Here we go. Why do I have to place this in a conf file? The documentation, the link is here. But here's a link in the Twitch chat. Changing the init manager has effects on the whole of the system. This means it is not limited to a specific recipe for a package or for an image. It can affect all of the system, so you need to put it into a configuration file. Anybody who's sitting in front of his screen right now, please say aloud: recipe data is local, configuration data is global. Say it aloud. Okay, this is really one of the things where people go wrong most of the time. They try to put things like changing to systemd in an image file and wonder why it doesn't work. That's the reason why. Is my build finished? Not yet, but almost. And then we'll hopefully have a really, really nice and small image offering systemd and all of its feature set. And while I hopefully boot up again, I hope for questions. I shall repeat the link. Here it is. Or if I have shall repeat anything else, just tell me, let me know what. If my reactions are slow, the reason is there's a delay of about 3 to 5 seconds between what I'm saying and when you receive my output, as it is. And I can't see the demonstration terminal and the chat at the same time, as I'm only on a laptop. It's time to do the pub thing. Ja, ertigern Sie, bitte. Jo. Because pub means drinks. And you can already see the boot up looks completely different now. It has got colors. Hooray, green colors. Green colors mean that things are good, right? And here it is. It's our first minimal image with an SSH server and running on systemd. It means that our image has become a little bit bigger, seriously, but sometimes it's worth it. I have to point out that it's not systemd alone. It's because the QEMU build sucks in a lot of kernel modules, which are usually not needed in a real environment. You usually know your hardware and things you want to bring in. So it's not exactly true that you can't have systemd in less than 40 megabytes. It usually has like 5 to 10 megs. It just looks strange if you have a demonstration on it. But now we can have journal control. We can see what's going on, list units, no, system control, list units. Those are all things that are going on this specific box right now, and I'm just checking for drop bear, and we can look into journal control unit drop bear, for example. No entries, and this is something that I really love for developing on my devices. I don't have to add markers onto debug output that then goes to syslog, and I have to grab for it and anything. Systemd just ingests everything, puts it into a journal, but also offers me the tools to tear it apart again and only see for specific things that I want. So this would be the second of my recommendations. Let me untangle my tongue. First thing is install dropbear, have SSH. Second thing is get systemd. You can flame me right now. It's okay. Systemd also brings you bus control if you need to manipulate or monitor dbus, but that's more of a rare thing. So another point. I see in the chat at Freenode if it's possible to comment on Twitch without having an account there. No, unfortunately not. That's why we explicitly offer Freenode as a secondary means, so you can just say hello to us without having to register or log in or anywhere. Usually, the Twitch account isn't meant anyways. Okay, isn't meant anyways. I'm only there during the sessions, but you can usually reach a good bunch of Yocto project developers through #Yocto on Freenode, and we also try to be responsive on Stack Overflow. It's often a bit complicated because Stack Overflow as a format is not exactly well suited for the things we do. There's a lot of low quality questions with wrong assumptions, and if you try to correct those assumptions, it leads to more wrong assumptions and misunderstandings. So usually it's really best to just reach out to us through #Yocto on Freenode or shoot us a mail on the mailing list. Those are the probably best ways to get in touch with us. Okay, so we have an SSH server. We have a big init system. Now we want more functionality. And the easiest way to get more functionality is to not go for coreimageminimal, which is minimal as its name actually says, but to go for core image full command line. And you will be seeing in a second what this actually brings. A lot of stuff, which I also prepared a couple of hours ago, because you can see that brings about 3,000 tasks to be done, and the root file system will probably be way bigger, but it offers a full bash and a lot of utilities, which I think it would be actually a good idea to have a look at. I think we should have a look at what this actually brings. Let's go. It's also a good idea to have a look at Pocky. Usually I do this quite early for reasons unknown. I've been distracted today. Let's have a look at Pocky. What is in Pocky? In Pocky, there's like three things bundled up. It's the core um, metadata from the Open Embedded project. This means a lot of recipes for the bare bones things like GCC, glibc, a lot of really common packages. There's bitbake in a specific revision matching the metadata, the second thing. And the third thing is a little bit of glue and distribution data to make up a combination that offers what I just showed you, namely um, taking the coreimageminimal and pushing it, shoving it right into QEMU. This is basically the special sauce. Speaking of special sauce, it's drink time. We're at the Yocto pub. Let's have a little deeper look at the metadata in recipes core. For example, there's core utils, drop bear, like I already showed. Let's have a small look if where's core image minimal? Core image minimal I already had. I meant full command line, and here it is. You can see this is the recipe that makes up core image full command line, and it means image features splash and SSH server open SSH. Yes, exactly. And it installs a package group core boot and a package group core full command line. Package groups are what their name already says, groups of packages that can be pulled into your image all at once. And let's see what core image full command line actually means. Here's what you can see that is getting pulled into the image by package group core full command line. It's bash, bc core utils, add find file utils, gawk, gmp grep, mc, ncurse, set, procps, all the shebang that actually makes a system usable in the common sense. So if our build is finished right now, we'll be kicking this one off. Kernel, and hopefully switch to systemd really soon. Here it is. Cheers. So I hopefully have a pretty much full-blown feeling system at my fingertips in 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. Oh, come on. The beauties of emulation. Everything is slow. Let's have another look. You see, this really brought in a couple of more megabytes, but now, hey, we have BC. We can do funny calculations. I mean, what's the answer to life, the universe, and everything? We need to be able to actually calculate that, right? We can have MC inside the image. There's the binaries. It's just like a full-blown Linux system by now. So, any questions so far? What what do you want me to show, discuss, break right now? What do you usually need in your images? Shall we shall we add some DevTools? Is this a good idea? I don't know. I don't have DevTools prepared. Um, Bruce was on time. I see. Great. Um, I don't have the DevTools prepared as pre-built, which means if I go ahead and try to install them, it will take quite a long time. But if nobody screams no in the next half a minute, I will just give it a try. Maybe not all DevTools, but something simple. How about strace? I think strace is cool, right? Everybody loves strace. I do love strace. So, what do we need for getting strace in our build? Usually we would add it to our image, but in this tinkering case, for the non-tinkering case, I repeat, watch the live coding with the Yocto Project session number 2 to be found on YouTube. Shall I drop the link in the Twitch chat? Just let me know if you need a link to it. Um, Usually you would add things like this to your image recipe. In this case, we are using core image. We are using the tinkering way through local.conf, and I hopefully have remembered it right. No, dang. Um, core image, core extra image install, core image extra install. We will see. Is a built-in variable into core image minimal, core image full command line. Um, to we should just check it. Why am I talking about it? You will learn way more if we just look at things. We will look at the images. We'll look at core image minimal, and here it is. It tells us what gets installed: core, its package group, core boot, and core image extra install. So core image extra install. Yay, I got it right. Let's build the image again, and then let's have strace. We're being a small bunch today. That would mean any one of you can get a more personal treatment by me, unshaven as I am. Oh, you can see just having strace means a lot of things to be pulled into the image. But hopefully this box is fast enough to actually cope with this in a reasonable amount of time. We still have some time budget left, so really shoot me questions. I'll try to answer them all as far as I can. Considering things coming up, I think I will be talking about WIC, the Open Embedded image creator in one of the next sessions, and I'm uncertain if I shall do something on kernel development, because kernel things can get complicated and crazy really, really fast, and this is what I want to avoid, because as you have all noticed, I mess up more than enough already for the simple tasks. And here's something. Here's something messing up my build already. The question is, adding custom drivers is also done by creating layers. Yes, of course. A driver in Linux is usually a kernel module. So you have to what's the word? You have to separate between drivers that are in kernel but not activated for your build, and totally custom drivers that are out of tree. Out of tree means they're not in Linux mainline, they're written by you and maintained by you, and usually tied to a kernel revision, which is painful but sometimes necessary. So there's a couple of ways. There's the way to stick to a mainline kernel and build things out of tree. Let me check the link for it. There's a pretty good explanation in the Yocto project documentation. So here you go. This is the link to out of tree modules. Those are basically, when it comes to Yocto, they're a recipe and a package like any other. You include a class for it, which tells Yocto a lot about the needed magic, and then I think we even have a pretty good example somewhere. Let me poke Richard about it. Is Richard? Are you listening? Can you just tell me on IRC if you are? Probably not. Let me poke folks. If we do have on Twitch out of tree. Okay, I shot this in IRC right over to one to the main developers, which are Bruce and Richard, for stuff like this. Mainly Bruce, who happened to be late, and probably not listening to what I'm talking about. So returning again. Yes, you always want to bundle up your stuff in a layer. It's bundling up your images, it's bundling up your packages, and it's bundling up your drivers. Your drivers could be out of tree modules, like the link I just pointed out, or you could have a kernel repository of your own that you have patched with your layers, so they become basically in tree from the point of view of Yocto. Those are the two main ways that people usually uh, can choose between. Whichever fits your workflow better is depending on your project, depending on your personal tastes and everything. But yes, it's like adding a custom application. I'm not sure if that answered the question. halfway properly. Um, let me think if there was a session on it. Richard says that we have a skeleton example, and he pokes Bruce about it. Very good. Thank you, Richard, in case you're listening. Um, I think there was a presentation on this during one of the EAL sessions. Let me check it for a second. Maybe I can find it. Um, EAL next oh. And here it is. This is the introduction to kernel modules presentation by Bian, who happens to be one of the core Yocto Project consultants and trainers that I'm aware of. I'm not, I haven't watched the video myself, but it should give you a good overview of how to get started writing the driver in itself, and for incorporating it into the Yocto project. The first link, working with the out of tree modules, should probably be fine. So what about my build? Oh, we're getting really close. I think that's also the last thing I'll be showing for you today, because as fast as we were in the beginning, we are now pretty much running out of time today. Not running out of beer. We're in a pub, and I don't mind if it takes a couple of minutes more, but um, folks are getting having dinner, are like streaming into the place, and they don't want a weirdo sitting in a corner and talking about Linuxy stuff. Usually they don't want that. Ja, bitteschön, wenn's auf Deutsch sein darf. Yeah, so, but usually streaming language is English. So I invite you again, join us at #Yocto on Freenode. There's usually somebody around during all times of the day. We have developers sitting in Australia and New Zealand. A good bunch of us are sitting in Europe, and even a bigger bunch is sitting over in the US. So during those times, you usually get an answer, not instantly, but within a couple of minutes, or at least in an hour or so, if we understand what your question is. I seriously don't get why strace needs Mesa. Can somebody enlighten me? That's really weird. And if that takes even longer and longer, I'll have to abort it. I just can't think of any more ways to talk myself out of just waiting. Waiting is boring. And watching our compilers churn and do funny things is really not that entertaining. Which is another reason to not do things like these in a VM. Do not ever try to build Yocto in a VM. You you're just in for a kingdom of pain and waiting, and even more coffee drinking until you have a heart attack because you are waiting so much. Okay, you can go develop a sword fighting, because reason number one for developers slacking off, my code's compiling. Strays really pulls in a lot of stuff, and all this for showing you that it works. If I had known, I'd picked something else. GDB. Note to my future self: if anybody of you um, joins me in a future session where I'm musing about showing off S-trays, tell me that I shall not show S-trays, okay? But I think we're finally getting close. Question is, if it's a good idea to activate Package Manager. Depends on whom you ask. If you ask me, totally no. Package managers are not what I want on a development on my embedded machines, because just having a package manager on the target does not mean that the packages will appear out of thin air. It means that yes, you can have a package manager on the target, and yes, on your server you will have to build everything still, and not only build, you also will have to set up it as a package repository, so that your package manager on the target can actually find and access it and pull it down and everything. So unless you have like super specific requirements for each and every device needing a specific combination of packages, or if you are just working for an operating system vendor, then it's totally valid. But for the common embedded systems developer, my answer is clearly no. I have never ever needed it, because once I know what I want, I can just add it to my image, rebuild, flash, be done. Whenever you fear losing your work on the target because you need to reflash, then you're doing seriously something wrong, because work on the embedded target has to be volatile. If you're developing in target, you do funny things, you make it work in some way, and nobody ever can reproduce it. Don't do it. I never ever do this. I do everything on the host, make sure I can reproductively build it, flash it, test it. So people and opinions may differ, but my answer is clearly no. I've never ever built a target where I needed package management, and I've been in the business for over 10 years now. I'm doing industrial controls, so your use case may vary, but for me, never ever. I hope this answers your question. So, hooray! Build. So, final countdown before I finally stop my session. Run QEMU. It took so long that my session has run out. What did I say about 10 seconds? I think I was wrong, right? It was like 20 seconds. And it's surprisingly quiet still, despite people for dinner showing up. I really need to wrap up soon. I seriously have no idea about why S-Trace pulls in all of those things. Reminder to my future self, maybe for the next session, if you're around, tell me to look into the dependency analytics to find out why something triggers something else. we have means for this, but I'm not able to talk about this anymore today. Okay? Thanks. So we hopefully have S-trace now, and just to show off, we do something super hilarious. S-trace blah bloop, or rather ASD, but we can see strace works in our target. We can debug there, and we're seeing the right and whatever I wanted to tell you. So thank you everybody who was around for joining me in this totally messed up vacation getting started session. I think I've never ever broke so much in so little time, but hey, that's business. That's live coding. And as a last thing from Bruce, the skeleton one in meta skeleton, I think it's in meta skeleton, should do fine for getting started with out of tree module development. If you have more questions, just poke us in #Yocto on Freenode. I'll be checking in later this evening. For me, it's now time to finish my beer, go home, have some quality time with the family, have dinner, and see you next time. Here's the thanks screen. Thanks for watching. Check us out on Freenode, on YouTube. Tell us what we are doing good, and tell us even more what we are doing wrong. Because only if you're telling us what we are doing wrong, then we can do better and we can make use in patches. Yes, that's the trick. So thanks and bye bye.